All right, everyone. So again, this is lesson 23, session 2. Lesson 23, session 2, we are starting on page 499. That is what you are seeing on your screen. It's the one with the oranges. My DL students, I am on slide number 54 now. Please make sure the deck is open on your device. All right, here we go. Let us take a look at page 499. We're going to talk about Carl and Trey and oranges. Here we go, where the pen is pointing. Carl eats 2/8 of an orange. Trey's orange is the same size. He eats 1/4 of it. Show that the two boys eat the same amount of an orange. Now, friends, I can already see that I'm going to have to find an equivalent fraction here. Why? Because I am seeing that there are two different denominators, pieces of the whole. I can see that Carl cuts his up into smaller pieces. I can see that Trey's pieces a little bit bigger. So friends, what I need to do in order for me to create this model and prove equivalency and find an equivalent fraction, I need to model each of their oranges with their respective number of pieces. So I need to draw Carl's orange with 8 pieces. How do I know? Because the problem tells me that. I need to model Trey's orange in 4 pieces. How do I know? Because the problem tells me that. And I need to show that the two boys eat the same amount of an orange. I need to prove that. So the problem is telling me, yeah, 2/8 and 1/4, it's the same amount. I'm going to say that again, that 2/8 and 1/4 are the same amount. But I have to show it. I have to prove it. And that's where your models come in. So friends, this is what we're going to do. And out of the interest of time, of course, I've started it. So what I've done is I have started Carl's orange. This is Carl's orange. And you can see that with Carl's orange, I cut it up into 8 pieces. And I cut it up into 8 pieces because that is what the problem told me that he did. So what did I do? I took something like this and I traced it because I do want to make sure that Carl and Trey have an equal size. Has to be equal, right? So what I did is I traced my little circle here and I'm pretending that it's an orange and I cut it into 8 pieces. That's Carl. That's Carl. But then I need to go that step further and show what Carl ate. All right. So of these 8 pieces, Carl ate 2 of them. Great. So here's a piece. We're going to color that in, right? Piece number 1 and piece number 2. Does the coloring have to be absolutely perfect? No, it does not, but we get the idea. There we go. I will give you a moment to complete that. And then we're going to be all done with Carl. But now we need to model Trey's orange. So we're going to do the exact same thing, but this time we're going to do it into 4 pieces. Why 4? Because that is what the problem tells us. So again, Carl has 8 pieces. Trey has 4. So again, same size, but this time, again, 4 equal pieces. And then I need to shade what Trey ate. And it tells me that he ate 1 of those 4 pieces. So am I going to color in 1 piece? Yes, I am. So down at the bottom, we can say that Carl's model represents 2/8. We can say down at the bottom with Trey that his model represents 1/4. And we can see through our model that the amount of orange that Carl ate and the amount of orange that Trey ate are the same. Because remember, friends, equivalency shows the same amount shaded or the same point on a number line, and we'll get to that in a moment. So again, the total amount eaten by Carl and the total amount eaten by Trey, it's the same amount. It may be fractioned differently, the oranges, but they eat the same amount. So yes, we have just shown that 2/8 equals 1/4. This is equivalent. Now, there is another way that we can model this, and we can model this with number lines. We can model this with number lines. So I do want to share that with you now. Here we go. This is where, of course, the ruler might come in. So now what we are going to do is we're going to draw a number line. We're going to draw a number line. And you can see that the number line, and I guess I'm color coding everything. You can see that the number lines in color represent each of their oranges. So you can see down here at the bottom, this green represents Carl's orange. Why? Because Carl cut his into 8s. So you can see that these green numbers on the number line are the same as the 8 slices on the model above. Just a different way to model it. And then you can see up at the top, the number line is marked into 4ths in orange. Why? Because Trey's orange is cut into 4ths. So I took the same hole, and on the bottom, I represented Carl. On the top, I represented Trey. Carl is 8ths, Trey is 4ths. So this is representing 8 pieces in the whole. This is representing 4 pieces in the whole. What are we trying to prove? What are we trying to show? We are trying to show that they ate the same amount. How can we show it? We can show it in this way. We can first see what Trey ate, which is 2/8. I'm sorry, what Carl ate, which is 2/8. And then we can match it to what Trey ate, which is 1/4. And you can see, friends, that it is at the same point on the number line. What Carl ate, what Trey ate represents the same point on the number line. And that, my friends, means that these fractions are equivalent. They are the same. They are equal. Given these models, can we do our cross multiplication, our butterfly multiplication, to confirm that and check our work? Yes, we can. We can take this numerator and this denominator, and that product is 8. We can take this numerator and this denominator, and again, the product is 8. I have double checked my models, and I can confirm equivalency. I'm going to give you a minute to get the rest of those notes written down. Again, please take good notes, friends, and then we are going to move on to page 500. All right, everyone, let us take a look at page 500 now. Up at the top, we're going to be talking about Carl's and Trey's orange. And it says, again, that Carl ate 2/8, Trey ate 1/4. We need to show they ate the same amount. This model is 2/8. We've seen that from the prior page. This model is 1/4. We also saw that. We can see that the model 2/8, the solid line divides the circle into fourths. The dashed lines divide each fourth in half to make 8ths. So friends, you can see this started as the same fourths. And then I just divided it again. Dashed lines, dashed lines. So here again, fourths. This was fourths divided again into 8ths. Same size whole. If we look down here at the bottom on the model down here, it says you can also use a number line, which we did. Again, the bottom is Carl, the top is Trey. Looking for equivalency, taking what Carl ate and seeing if it matches what Trey ate. Is it the same place on the number line? And we have confirmed that it is. Again, cross multiplication. We'll check your work and we'll prove it. These two fractions are equivalent. Again, I'm going to give you just a minute to kind of catch up on your notes here. All right, friends, on 501 up at the top, it says, now you will use the problem from the previous page to help you understand how to find equivalent fractions. Again, equivalent fractions. We have a number of questions here. a number of questions here. The first one says to look at the models in that green picture it on the prior page. How do you know that 2/8 of the first model is shaded? How do you know? Well, how do you know? You know because there are 8 equal parts and 2 are shaded. There are 8 equal parts and 2 are shaded. The next question is asking, how do you know that 1/4 of the second model is shaded? There are 4 equal parts and 1 is shaded. There are 4 equal parts and 1 is shaded. So again, 8 is Carl, 4 is Trey. And question 3 is asking, explain how the models show that the fractions 2/8 and 1/4 are equivalent. Very, very important here, friends, on question 3. How the models show that the fractions 2/8 and 1/4 are equivalent. The wholes are equal in size, and the amount that is shaded is the same. The wholes are equal in size, and the amount that is shaded is the same. On question 4, it is asking, how does the number line in that green modelet show that the fractions 2/8 and 1/4 are equivalent? So again, friends, when we are looking for equivalency, it is not just the same amount shaded, it is also the same point on the number line. 1/4 and 2/8 are located at the same point on the number line. And so remember, friends, we also put words to numbers. So if it is ever asking you to do that, use words. 2/8 is equal to, if I'm asking you to use words, this is what I'm looking for, friends. You are actually writing the word 1/4. 1/4. Two eighths is equal to 1/4. And then to use fraction, again, 1/4 in words, right? 1/4 in fractional form. This is the same value, 1/4, 1/4. In number 6, it is saying, describe 2 different ways to show 2 fractions are equivalent. So what this question is asking you on number 6 is to basically put into words what we've done on the last 2 pages. Now you need to describe what we did. You need to describe it. All right, so for number 6, it is saying that you can see if they show the same amount in equal sized area models, or you can see if they are at the same point on a number line. Again, you can see if they show the same amount in equal sized area models, or you can see if they are at the same point on a number line. And I want you to go back, for example, to these two that I drew on page 499, where again, you are seeing it is the same amount in those equal sized area models, or it is the same point on a number line. That is how you show equivalency. All right, friends, I'm going to give you just another minute or so to get this down, and then we are going to come back together briefly